Hi folks, welcome once again to a Gaz Labs little video. Today I thought I'd do something a little more interesting. It's quite a detailed video and it did actually take quite a long while to sort of set up. The actual work itself is kind of almost real time. Now when I did the AirSpy video with the FT8 and setting up sort of plugins and stuff on the SDR Sharp, I had quite a few emails, people asking me what antenna was I using. Well, in my case, I'm actually using a high gain DX88. Now, it's vertical, it's quite an ugly antenna, but it does actually work quite well. But I just wanted to sort of show people, because a lot of people sort of said to me, well, I don't have room for a larger or a vertical or a wire antenna or any of that sort of stuff, and all I want to do is listen. Well, actually, that's not impossible. You can really do this on a very sort of tight purse strings. And what you can see here is I'm actually building a very small Magloop. Now, okay, it's not going to be very efficient for transmit. You'd probably be able to max transmit into this probably 5 watts, I would have said. I mean, you can actually take one of the VariCap if you're familiar with the wafer type capacitors from a transistor radio, you can actually use one of those on a 65-foot piece of long wire and actually transmit very like a Pixie or something like that into it, and that is a really good way of tuning just a long wire and getting a very low sort of something. For something like Whisper, it would be absolutely perfect. Now, this here is just a very basic airspace capacitor, which I picked up at the Didcot rally. It cost me £1, I think, something like that. And in there you can see that I've actually got one of the Como drill motors. Now, I'm actually going off that idea. I'm probably going to go with either a stepper motor or a servo. Now, I'm not really sure how I'm going to do that yet, but I'm going to probably put an Arduino in there and then just use sort of something like a servo controller or a stepper motor controller. That would actually be probably the best way forward with that. And that also would mean that I could potentially set it up with memories and bits and bobs. Now, and with SDR Sharp, I could probably install some kind of plugin that would give me, like, say, cat commands to an Arduino, and then that as you tuned the SDR Sharp software, it would then tune the antenna to suit. Now, here you can just see I'm just cutting off link wires now that are going to take the outer of the SO239. I'm not interested in the center. You don't need it for what we're going to do. And then the most important thing, T, because you're only using the outer part of the coax, and the coax that we'll come on to in just a second is a bit of Broad Pro, and all it is a 1.5 meter patch lead. Now, I made this up specially for this, but if you've got like a longish patch lead or something kicking around, it will work absolutely fine. The only thing you've got to do is produce sort of like something that's called a Faraday loop, which basically is the parasitic loop which will give you your match. Now, there is a ratio for that, which I off the top of my head, I think it's either 3-to-1 or 5-to-1. Can't remember. I think it's 5-to-1. So basically, you take your outer diameter of the loop that you make with your patch lead, and then divide that by 5, and that will give you the loop size on the inside. Now, you can play around with that, and what you're actually looking for, what effect that has actually, is it's the impedance versus SWR. So what you're trying to do is you're trying to get the size of the parasitic loop or the Faraday loop the right size, so that at a given SWR, the impedance is 50 ohms, and you can change the shape and you can do all sorts of things. So just using sort of something like an analyzer is a really good way of doing that. Now here you can see I'm just tinning wires, very boring, but you've got to do it. So you know, you just get the ends tinned and get it hooked up onto those eyelets. Now, it was quite a while ago that someone sort of mentioned to me about the good things about Magloops, and that was G4KKI. A good friend of mine then, he unfortunately silent key now. Bill, he said to me, you know, basically try Magloop if you've got no space. And he showed me all sorts of things to do with these little antennas. We made rock loops and mag loops and all sorts of things. And if you guys Google 2E0 TIG and Loopzilla, you'll see Bill and his granddaughter actually putting those the early loops together. Now I ended up making a few of them, which got sent off all over the place. And I was making them out of old signpost, a system called Signpole 80, I think it was. Yeah, it was just basically bits of this old signpole that we were throwing away at work, and yeah, so good stuff. Now I'm just drilling some access holes here. Please mind your fingers, and look out for burrs and stuff if you drill through any alley or anything like that. I did actually manage to catch a little bit of the capacitor on this and get a little bit of swarf in my finger, which I didn't video, sorry. I'm just taking the edges off the plastic here just for jazz. You don't have to do that, but it just neatens it up. Now this is quite a fiddly job to get it all back together again, but it does go eventually. Now you'll see here that I'm just working out really how best to do it. Now I probably will change that round because if you see on there, the screws are quite close to that. If you're going to use it for transmit, the screws are quite close to that SO239, and they go into the chassis. And what I've done here is I've taken this cable, because it's closer to the actual fins of the capacitor, and that could actually arc across if you do use it for transmit. This is capable of generating quite a few thousand volts at sort of 5 watts. You're probably talking, you know, probably I'd say anywhere between sort of 750 and 1500 volts, just depending on you know how you do it. One thing to bear in mind about loops is that there is current at the closed section and there is voltage at the capacitor section, and they're completely 180 out of phase. So you don't have any current at the capacitor, but you do have a lot of voltage. So don't put your fingers in any of this sort of stuff when transmitting it. It can be quite painful. So here I'm just connecting the pieces up, and yeah, it's quite a fiddly little job to do, but we will get onto some good stuff in a minute, I'm sure. But what I'll do is I'll leave it here just for a minute and just let you run through this. I'll chime in if there's anything that I feel is important to mention. Just about now, I'm actually working out something here. I've noticed that the actual terminal is very close to it comes through the chassis of the capacitor, And what I'm looking for in my toolbox is some heat shrink or sort of something that will just insulate that that inner terminal from the outer, so that if if you were transmitting in there, that it didn't arc across, or there was no risk of the terminal being bent when the wire goes in and touching across. And what I've done now is I found a little bit of the outer of the coax, and I'm just cutting it up now and just trying to work out how to get it in there. Now, just before anyone sort of says, oh, what a Heath Robinson job you did and all that, at the moment this is just proof of concept. I'm just nailing this together with bits of tape and all sorts of things just to get it to work, and show you guys just the process of how I do these things. Some people might be able to do this, work all this sort of stuff out, but for me, I'm sitting just listening to the radio and just basically pottering around before bed, basically. And so what I've done here, just tin the wires just so that I can get these cables on. Now these are really, really quite tight and fiddly to get in there. Now you actually want to keep these cables as short as possible. You don't want them too long, and you certainly don't want them coiled up sort of too much. Now again, like I said, I'm just tinning this together, or pinning this together, really just to sort of see whether it's going to work, and whether or not it's going to actually tune okay on various bands. Now what I'm aiming for is basically 10 meters through to 40 on this. I know that the capacitor has enough of a value to actually to do that, but I'm working out. I just want to pin it together, just see whether or not I've got to use half the capacitor or the whole one. I'd rather not use. The more capacitance you use, the more inefficient the loop becomes. It doesn't matter so much about receive, because obviously it either receives or it doesn't. But I'd like to be able to use this, I think, just for a test on, say, something like FT8 or sort of something like that, or a little digital mode, just to see whether it will, if it will actually transmit and there is any success. I might hook it up for sort of something like Whisper or something like that. I've got a little 817, and you'll see the 817 towards the end when I basically prove everything's working. Now, at one point through this, I actually do discover that the capacitor doesn't have enough value to get to the to 40 meters that I want. So what I do is I basically include the other half of this capacitor to give me a little bit more capacitance, and that was very successful. And as I say, at the end you'll see the results. Now this is quite tight, putting this back together again. It does not want to go back in, and this is one of the things that I've noticed with this motor is going to be far too fast. It's only a 3-volt motor in this particular case. Beggars can't be choosers and all that sort of stuff. Basically that is a junk box motor. It came out of the box, and I assembled it, and then just thought, you know what, it's going to be far too fast to actually to tune. And the other thing as well, with anything like these DC motors with a lot of gears, you get a lot of inertia. So as one sort of motor starts to spin, or the armature starts to spin, when you actually want to stop at a particular tune point, what happens is that the armature just carries on spinning, and of course it can be enough just to get the loop completely out of tune. Now at this point I'm just putting together the patch lead. Now I'm just going to do one end, just to sort of some people might like to know about plugs. Now this particular cable is a cable that we sell at work. This is M&P, and this is just an offcut that we had laying around of Broad Pro, and it is a very stiff cable, and it's quite useful for that. So you can see here that I'm just working out how this plug goes together, because it's not actually an M&P plug. This one, it's a Rally Raid. It was £1. I bought 2 plugs for £2 at the Rally and at Didcot, and yeah, so excellent. And I guessed them as well, so I'm actually surprised they fitted. He just had a box there, and I just picked the 2 plugs, and away I went. And if anyone wants to know those scissors that I was using there, they're M&P scissors. They're really good for all this sort of cable sort of stuff. They're excellent. Yeah, the little top hat goes in, pushes up inside, and that traps the actual braid in between the 2 washers. And you want to make sure that's fairly good, and you just trim these little edges up. It doesn't have to be really neat. It's no risk. All it is, you're looking to stop the little hairy bits just trapping over. Now this is actually quite awkward for me to do, because obviously on top of this there's I've got a mobile phone which is videoing this, and it's only a few inches away from my hands, so I'm kind of doing this very cat-handed. Now I'm just checking here that the length is sort of somewhere close, and I'll just trim that inner foam away. And that knife is, I've had that for many years. That's a brilliant Swiss Army knife. Yeah, one of the best purchases I ever made. This here, I'm just discovering there's a burr on the end of the cable, so you'll see me get the file out. I've got one of these little Stanley click-on or sort of clamp-on vices. I'll put a link in the thing below for this vice, actually, because it's really neat. It's again, that's a very good purchase. It's clean, neat and tidy, not greasy or anything like that, and it's really good for sort of doing cables. And it just goes in the drawer when I'm not using it. So yeah, I'm just taking that burr off. It's actually quite a big burr. I don't know how I managed to do that, but anyway, it doesn't matter. It's gone now. And that should just pop straight on. This is a very similar cable to Westflex, sort of same sort of feel to it. I'm told that, and I've looked at the figures, and it is quite impressively, good quality cable. Now, I will tighten these up with a spanner when I'm actually sort of, I've completed. I just wanted to get it together for a test, so I just used an adjustable and just nipped it up in the vise, but it's not tight enough yet. Now, most important thing. Now, see here. Oh, right. Yeah, so all I've done is I've taped a piece of fiberglass fishing rod on the back of the box. I've connected the 2 pieces up, obviously, as you can see here, and all that is a loop of that is the patch lead basically looped across the 2 SO239s, and I've taped the loop and everything to the stick. Now here, this is the parasitic loop. Now you can see how this is made up. There's nothing complicated about that at all. What you need to do is that needs to be sort of somewhere between 1/3 and 1/5 of the size of the main loop. And what you do is you basically just you use pi just to calculate the size of that loop, and then what you would do then is you just solder the inner to the outer, and you can see just there, if I get my thumb out of the way, Just holding it on there. Yeah, it's just there. You can just see that I've soldered the inner to the outer at that point just to make up that little loop. And what that does is that creates just the inductive loop to the main loop. There is no electrical connection at all. Now at this point I've now got it hooked up to a radio, and proof's in the pudding. I'll leave you listening to this. Just very, very quickly, here you can see that I'm peaking for noise, and just as you tune off, you go off of the peak and you have to retune. I'm quite surprised at just how good the bandwidth is on this. It's actually a lot better than I was expecting. Okay guys, I'm going to leave it here, and thanks for watching. Please subscribe, thumbs up, thumbs down, that sort of stuff, and yeah, till next time, thanks very much for watching. Teddy bye.
Yankee Tango 5 America, contact. November 2, November Tango 59 kilowatts. Thank you, QRZ, Yankee Tango 2, Yankee Tango 5 Alpha. Yankee Tango 5 America, Yankee Tango 5 Alpha, contact. Heading to 4 X-ray Lima. Kilo 4 X-ray Lima, 59 kilo. Any Bravo Juliet? Japan 59500. Thank you, India Radio 4 X-ray.